Day 16 of 90 focused on custom errors and error patterns. Today I wanted one thing to feel clear: treating custom errors and error patterns as part of the program contract instead of as cleanup code. The goal was not to memorize a stack of tools. The goal was to pin down the service rule first, because once that boundary is visible, the implementation starts looking like a coherent flow instead of a scramble of conditionals. The first checkpoint was decide what the caller should know about a failure before returning any error value. That matters because a good solution should let me explain why the next move is legal, not just show that the code happened to pass one sample input. If that rule is visible, I can rebuild the solution even if the example changes. The second checkpoint was wrap context, where it helps debugging and avoid turning every error into a brand new taxonomy. That is the part that turns the topic from an abstract label into something operational. I can read the input, decide what state deserves to survive, and ignore the noise that will not help the next decision. The implementation shape only earned trust once I kept returning to the last rule: keep the happy path readable while making the failure path honest about what can actually break. That is where the code stops being decorative. Every update either protects the service boundary or it does not, and that makes the debugging path much cleaner. The common breakdowns were predictable. The first one was returning raw failures with no context and forcing callers to guess what broke. The second was wrapping every error mechanically until the signal is buried under noise. Those mistakes look different on the surface, but both come from letting the state drift away from its original meaning. I also wanted a compact practice plan, not a vague note to build more services later. My rule was to state the service rule, trace one request path, and then confirm that each dependency still tells the same story. That kind of drill is small enough to repeat but strong enough to expose weak reasoning quickly. What helped most is that custom errors and error patterns now feels like a repeatable engineering decision. If the load pattern changes or another service gets involved, I still know what question to ask first. That is the signal I wanted from today's work, because it means the lesson is portable instead of tied to one toy example. So my recap for day 16 is simple: treating custom errors and error patterns as part of the program contract instead of as cleanup code. The useful anchors were decide what the caller should know about a failure before returning any error value, wrap context where it helps debugging and avoid turning every error into a brand new taxonomy, and keep the happy path readable while making the failure path honest about what can actually break. When those are visible, the code is easier to test, easier to explain, and much easier to repair after the first wrong attempt. One more reason I wanted this locked in is that harder production scenarios usually change the surface details, not the core service rule. If that rule still survives, I can adapt the implementation instead of restarting from zero. That is also why I care about ownership so much in Go. Once the package boundary is honest, the rest of the code has a much better chance of staying boring in the good way. A lot of debugging time disappears when the request path or data path is obvious from the structure. The language helps, but only if the design is pulling in the same direction. So the real test for me is simple: could I explain this same design tomorrow with a different example and still keep the same rule intact? If yes, the lesson probably landed. I also like asking where the first confused teammate would get stuck. That question usually points straight at the place where the boundary is still implied instead of written down. When the code is shaped well, the packages, functions, and error paths tell the same story. When they do not, the mismatch shows up in review long before it shows up in production.